Welcome back to 3.3, Understanding Linear Equations with Two Variables. So instead of just having like an x or just a y, we're going to have both x and y, or two different variables depending on what the problem asks for. So your warm-up today is write an algebraic expression for the statement 8 is 4 more than y. So I want you to write an expression, or an equation actually, that represents that. Okay, go ahead and pause and work on that while I keep going. So this is kind of a lot of story problems, but I think you guys will understand these better than the ones we talked about in class today. So I want you to represent a relationship between two variables using a linear equation. Okay. So the first question is, Dorothy has a younger brother, Ben. The table shows their age over 5 years. And they want you to write a linear equation representing their age. So if you look on your notes, you can see you have this table. And let's just talk about the table a little bit. So we have Ben's age in 2008, 2009, 2010, 2011, and 2012, as well as Dorothy's age. So Ben is 1, 2, 3, 4, 5, which makes sense. It should be in order because it's consecutive years. And then 4, 5, 6, 7, 8. So what is the age difference between Ben and Dorothy? Notice each time it's plus 3, right? They're 3 years difference, and then 3 years difference, which makes sense because siblings are obviously going to stay the same age apart. So I wanted to write an equation that shows Ben's age in comparison to Dorothy's age. So what I might say is I'm going to let Ben equal X years old. And I'll let Dorothy equal Y years old. Okay. So again, I just chose X and Y. You could have chosen B and D, however you want to do it. But it's good if you write it off to the side so you remember which variable is with Ben and which variable is with Dorothy. Okay. If you use B and D, it'll be pretty easy. So what I might say is, well, I know that whatever Ben's age is, I'm going to add 3 years to get Dorothy's age. So I'm going to say Dorothy is, or equals, whatever Ben's age is, which is X, plus 3 more years. So this would be one way that I could represent Ben's age according to Dorothy's age. I could also say this slightly differently. I could say, well, Ben is equal to Dorothy's age minus 3 years. Okay. So this would be Y according to X, and this would be X according to Y. Okay. So there's two different ways you could have represented that linear equation. Okay. And either way would be correct. All right, and let's move on. So the second example. Mrs. Ford heated a liquid and measured its temperature. She recorded the results in the following table. So she's writing down all her temps and her times. Write a linear equation for the relationship between time t, so time we know is represented by a lowercase t, and the liquid's temperature. So temperature is measured by a capital T. So this is really kind of confusing sometimes because they'll use the same letters, but they'll use the uppercase and lowercase. Okay? But this would be something in a science class that you would see. So I'm noticing lots of stuff in my table here. So again, I'm just going to look at my table and see what's going on. So at time 0, I'm at 20 degrees. I'm sorry, 25 degrees. At 1 minute, I'm at 30 degrees. At 2 minutes, I'm at 35. 3 minutes, I'm at 40. And 4, I'm at 45. So at time 0, that's called our initial temperature. Okay, so that's 25 degrees Celsius, which I don't think I put that in the problem. So this is in Celsius and time is in minutes. I apologize for not writing that earlier. Okay, so now I'm going to think about this. If I look at this, each time I go from 1 minute, I am adding 5 degrees Celsius. And then here I'm adding another 5 degrees Celsius, plus another 5 degrees Celsius, plus another 5 degrees Celsius. Okay. So I'm going to make another little chart to help me make this equation. Okay. So time t was at 0, and then 1, 2, 3, 4. So this is my temperature. So that is 25 is my initial, right? Which would equal 25 plus 0. Okay. And then 30 is equal to my initial temperature plus 5, right? And then at time 2, it's at 35, which is my initial temperature 25 plus 10. And then at time 3, it's 40, which is 25 plus 15. And then 4 minutes is at 45, which is 25 plus 20. Okay. So if I rewrite this just a little bit here, this is still 25 plus 0, which would be 5 times 0, because I know I'm increasing by 5 every time. And here, it's 25. 5 is 5 times 1. Notice how these little t's are matching up with what I'm doing here. Okay. And then 25 plus 10 is 5 times 2. See how that's matching up with my time here? And this is 25 plus 5 times 3, because 15 is 5 times 3, 10 is 5 times 2, in case you're not seeing where I'm getting that information from here. And then this would be 25 plus 5 times 4. Again, 20 is 5 times 4. So this is just to help me set up the equation. You might be able to understand the equation easier than this. So then I know my equation is going to be the temperature is equal to my initial 25 degrees plus 5 times whatever the minutes is. Because see how this is always equal to t here, the little t? It's always equal to 0, and then 1, then 2, then 3, then 4. And I'm increasing by 5 each time. And this here was my initial temperature. Okay, so that might take some time to work out, but if you notice, you can say, okay, well, I'm starting at 25 and then bumping to 5 and then adding another 5, so this would be 2 5s here. And then at 3, it's 3 5s that I've added. Then at 4, it's 4 5s I've added. So it's 5 times whatever the time is. Oops, sorry, you guys probably can't see that. Okay, so there's multiple ways to think of this. If the chart helps, make the chart. If you can just get it from this, that's fine too. Okay, so practice this. That's the most important part. All right, now another one. So this last example here. George rented a car, not care, car, from a company for a week. The table shows the rental charges. So now we want to make an equation that shows how much he's being charged, or how long, if we went for 3 hours, how much would it cost to rent this car? So we have distance in d miles. So little d is representing distance, which makes sense. And 0 distance, 1 mile, 2 mile, 3 miles. And then the rental charges in C dollars, C for charge. So my initial is you pay $100 for the car. And then it's 110 cents for the first mile. It's 120 cents for the second mile. So we're adding 10 cents, right? For every mile that I go. And I believe your chart goes to 4, but I kind of ran out of room. So 10 cents, and then it goes up to 10 cents again. And it's going to keep going up to 10 cents every time for each mile after my initial start. So my initial is $100. Okay, so I could make the same chart that I did in the first problem, but I'm just going to kind of go with it. So I know that my C charge is going to be $100 for sure, no questions asked, plus 10 cents for every mile, or D, that I drive afterwards. So that's 10 cents times the amount of miles I go. Okay. And this would be my final equation here. So I know I'm charged $100 right off the top for the car, plus 10 cents for every mile afterwards. So it's 10 cents times D. Okay, go ahead and pause it if you need to go back and look at that for a second. That one was kind of quick. There's no exit slip today because all of them are story problems, so that would be really complicated to make you guys do out another story problem without just doing the homework. So I gave you guys a break. Your homework is page 116, 1 through 3 odd, or that should be 1, oh, it is 1 through 3 odd. So you guys have some easy questions today, and 21. Okay, so what? 3 questions, 1 through 3 odd. So you guys can do it. Have a great day. We'll talk to you tomorrow. Bye.